Welcome all of you. So the remaining questions from the course Automata Theory we are going to discussing in today's session. So the very first question which is remaining, that is write a CFG for language A raised to n B raised to n where n is greater than or equals to 0. That is the first question. So basically as they are given, write a CFG. So we have to find out the context free grammar for the given language. So first of all you have to write down the definition of CFG. So basically the CFG which consists of 4 tuples V, T, S, P that you have to mention in detail. V means what? It is a set of non-terminal symbols generally represented by uppercase alphabets. Then T is the set of terminal symbols, and likewise you have to mention all these things. Then S is the starting symbol and P is the number of productions or set of production. So V is nothing but that capital S. We are taking here terminal symbols as a AB, and P is what? S tends to ASB. That is the first production, and second production is S tends to AB. And L of G. So language, whatever we have to write, that is a W where W is belongs to T star and S tends to W belongs to G. Now, if you see here, S tends to ASB. So if you take the first production, that is the first production, that S tends to ASB, okay, and again if you apply this S tends to AB over here, again if you apply S tends to AB, ASB over here, then it will be extend like this, that AASBB, okay, means I am going to repeating this ASB over here. Again if I go for repetition, then it will be A cube S B cube, likewise A raised to 4 S B raised to 4, means repeatedly I am using this production only, okay. So finally for computing n minus 1 time, means if we are computing this S tends to ASB for n minus 1 time, it will be gives us A tends to n minus 1, yes, B tends to n minus 1, okay, fine. Now A raised to n, B raised to n, so A raised to n, B raised to n means after this step we have to looking for S tends to AB, means whatever the productions are given, by that production the first production gives us A raised to n minus 1, yes, B raised to n minus 1, by applying S tends to ASB for n times, and once you apply that for n minus 1 times, go for the second production, that is S tends to AB. So that S tends to AB will be replaced in the production and it will be gives us A raised to n, B raised to n. So that is the result. Okay. So don't think about the remaining part over here, and you can go for the derivation tree. So derivation tree, what will happen? Initially S will be there, on the LHS A will be there, on the RHS B will be there, and in middle again S will be there, okay. Again you will be go for S tends to A will be here, then S tends to S will be here, and S tends to B will be here, and likewise this procedure will be going for n minus 1 states, and once you complete n minus 1, you will be going for S tends to A B. So that will be gives us a result. So that's it for A raised to n, B raised to n for n greater than or equals to 1. I hope that you should got this idea. Now going to the second question in today's discussion. So question is what? Prove that L1 and L2 are context-free languages. Then language L1 union L2, L1 concatenation L2, L clean are also CFL. Means if two languages are given to you, that L1 and L2, and both are context-free language, then union, concatenation and clean operation also the context-free. So basically we have to take here two grammars G1 and G2. So what is the G? G is nothing but V1 summation P1 S1, and G2 is V2 summation P2 S2, okay. And that grammar G1 and G2 both are generating L1 and L2 respectively. So that is the terms given to you. Now in the case of union, what actually we are going to do in the case of union? See here, So GU, that is the resultant grammar after union, which gives you phi u, summation, SU and PU, and which will be generating L1 union L2. That is G of L1 union L2. So that will be generated after union operation. Okay. Now, if necessary, we rename the elements of V2, then phi1 intersection V2 should be equals to phi. So VU means what? Non-terminal symbols after performing the union operation, which will be phi1, phi2 union SU. SU is nothing but the new starting symbol which will be after union operation. So that is nothing but the non-terminal symbols. You can see here, phi is the new starting symbol in phi1 and phi2. Then next one, PU. Set of productions will be what? All the productions from first grammar, all the productions from second one, and union with SU tends to S1 or S2, because we don't have idea whether the new starting symbol SU goes to S1 or it goes to S2. So that's why we have written this like this. If X is in L1 or L2, then SU tends to X with clean operation. SU tends to X with clean operation. In a grammar U, because we start the derivation in SU tends to S1 or SU tends to S2 and contain the derivation of X in G1 or G2. Hence, L of L1 union L2, which is belongs to L of GU. Okay. So if X is the derivable from SU in GU, the first step in the derivation must be SU tends to S or SU tends to S2. Okay, because as we are taking here new starting symbol SU, so it should be derived towards the either S1 or S2. In the first case, all subsequent productions must be productions in G1, because no variables in V2 are involved, and this is X belongs to L1 and second case X belongs to L2. Hence you can write here L of GU, which is equals to or which is belongs to L1 union L2. So that is for union operation. Then next one, concatenation, very simple. So in the case of concatenation, what are the tuples should be there? Again, we have to take the two productions, we have to take the two grammars, that is the G1 and G2, and then from G1 and G2 you will be got this one, that is the GC is equals to phi C summation SC and PC. So and it will be generate you L1 concatenate L2, and keep in mind L1 concatenate L2 which is not same as L2 concatenate L1. Okay. So what we have to assume here, phi1 intersection V2 should be equals to phi, means they are mutually disjoints, means all the non-terminal symbols from G1 should not be equals to all the non-terminal symbols from G2. Then VC means non-terminal symbols after performing the concatenation operation, and it will be phi1 union V2 union SC. That is very important. These are the terminologies has to be written in the examination. And what is meant by PC? So all the productions from P1, all the productions from P2 union SC tends to S1 dot S2. So basically here new starting symbol SC is going to take, and from that starting symbol SC you have to go to S1 concatenate S2. Previously what was there in the case of union? It was SU tends to S1 or SC tends to SU tends to S2 was there. But here we are going to take here SC tends to S1 concatenate S2. Now we have to think about X, which is belongs to L1 concatenate L2. X belongs to L1 concatenate L2. Then you can say here X is equals to X1 dot X2, where X of I is belongs to L of I. For I, we may then derive X in GC as follows. Okay, so you can see here SC, which gives you S1 concatenate S2, S1 concatenate S2, so that X1 X2 will gives you X. That is very important, where you can say that X1 is in G1 and X2 is in G2. And finally by concatenating x1 and x2, it gives you x. If x is derived from SC, then SC is equals to S1 dot S2. X must be derived from x is equals to x1 x2. Okay, so that's it. That's it for the concatenation. That's it for the concatenation. And the next one, clean operation. Again, it is very important, and which is applying on a single grammar. Let us consider one grammar is given to you. Let us say G is the grammar which having VTSP. You can see here VTSP or V summation SP is the grammar given to you. And by using that, we have taken the clean operation, that is the G star. And G star also gives you V summation SP. Then what is the meaning of that tuples V summation SP? So V is nothing but the all non-terminal symbols. So V is the non-terminal symbol from the existing G and union S1. So may possible that after performing clean operation, S1 will be the new starting symbol. So that's why phi union S1, that is the thing. And what they have mentioned, S1 which is not belongs to V1. So S1 which is not belongs to V1. So L1 star contains string from. Now in the case of concatenation, what we have taken, X is equals to X1, X2 and so on up to Xk. Where X of I belongs to L1. Now for each X of I is derived from S, then to derive X from S, it is enough be able to derive a string of K, comma S, S. So S tends to S1, S or null in P. So that is again important terminology. This terminology you have to keep in mind. And finally productions P will be what? P1 union S tends to S1 yes or null. So these are the things you have to keep in mind and write in the examination. Okay, so that is about clean operation. You have to keep this in mind. This is about clean operation. Okay, now take the next question. Ambiguous grammar. What is meant by ambiguity, or it is also called as a impurity? So ambiguous grammar explained with the example. So what is meant by ambiguity? Ambiguity is nothing but the impurity. When the given grammar is said to be ambiguous, if that grammar derives more than one tree for the given set of productions, then it is called as a ambiguous grammar, and the trees are called as a ambiguous tree. So you can see here, in the case of CFG, they call as ambiguous if it contains terminal string with more than one parse tree, as I said earlier. So for the given set of productions, it gives you more than one parse tree, more than one leftmost derivation or rightmost derivation. It is depend. It gives you more than one leftmost derivation or rightmost derivation. So if you see here one grammar and it having some trees there. So dt, that is the derivation tree 1, dt2, that is the derivation tree 2. So if the given grammar gives you two derivation trees, that is this one is the first one, this one is the second one, then it is called as a ambiguous grammar. Then it is called as a ambiguous grammar. Now take one example and we verify what is meant by ambiguity. Let us consider one example which consists of, that is a grammar phi summation SP, and they have given here tuples. What is meant by G? This S is the starting symbol, A is the terminal symbol, P is the set of production, and S is the starting symbol again. So what they have given, V is nothing but S, summation or T, that terminal symbol as A. Then they have given productions. Total 3 productions are given. The first production S tends to AS, second production S tends to SA, and third production S tends to A. And what we have to do, by using this we have to draw the derivation tree for AAA. Okay, by using this production you have to draw the derivation tree for AAA. So these are the possible results. So starting with the production, what is the production? S tends to AS, SA, A. So if you go for S tends to AS, this is possibility. S tends to AS, that is the possibility. If you go for S tends to SA, that is the possibility. Okay. And again, if you go for S tends to AS, this will be happen. S tends to SA, this will be happen. And S tends to AS, S tends to SA. That is the term. And finally, as they are. So as they are, this one is terminal, this one is terminal. Okay. So whatever the lowercase letters these all are terminals. Okay, so all these are terminals. So only yes is remaining. For that yes, we will take the third position. Third position is what? This. If you take this one, then what will be happen? You will be give here A. So if you see all these four diagrams A, B, C, D. So this A, B, C, D which gives you string read as a. It reads A. But there is a difference between this diagram, this one and this one. So these are the four ways to represent string A. So the given grammar, this grammar is said to be ambiguous grammar. This grammar is said to be the ambiguous grammar. Keep in mind what is meant by ambiguous grammar. Fine. Now moving towards the next part, what is meant by Chomsky hierarchy. So basically Chomsky hierarchy, which is related to the types of grammar and types of languages, so which is designed by or which is introduced by Noam Chomsky. And according to the Noam Chomsky, the Chomsky hierarchy, which consists of four types, that is the type 0, okay, then type 1, then type 2 and type 3. So type 3 means which is the subset among the all. Type 3 is the subset among the all, and which is nothing but the regular language. Means regular language is nothing but the type 3. Then in case of type 2 is a context sensitive. Okay. Then type 1, that is once again I am repeating here. Type 3 is nothing but the regular language and which is accepted by finite state automata. This one I am highlighting here. This one which is accepted by finite state automata, that is called as a type 3 and which is accepted by regular language, which accept the regular language. Then type 2, that is called as a context free, and this is the portion for context free. Whatever the portion I am highlighting, that is the portion for context free and which is accepted by push down automata. Then the type 1 is nothing but, here is the type 1, that is nothing but the context sensitive. Okay, so context sensitive which is accepted by linear bounded automata or Turing machine with the halting acceptance, and the final unrestricted. So unrestricted which is accepted by Turing machine with halting acceptance, halting resistance or any type of Turing machine, and which is more powerful. That's why it is called as unrestricted. There is no any unrestriction for type 0. Type 0 is the most powerful, okay, and type 3 is the lowest one. Type 3 which accepts the regular language and finite state automata. Type 2 which accepts the context free language and push down automata. In the case of context sensitive, which accept the linear bounded automata and Turing machine with the halting acceptance, and unrestricted which is more powerful, which accepting Turing machine's halting resistance problems. So that is the Chomsky hierarchy. We will be explaining this one by one. So see here what is meant by unrestricted grammar. First one, it is called as a type 0. There is a no restriction of grammar. The production of a from alpha tends to beta where alpha is not belongs to null. So the production alpha tends to beta means on the LHS of the production there should not be null transition. That is the restriction. So alpha comma beta belongs to phi union T star, proper subset. Okay, so that is proper subset. It includes all format of grammars, recursively enumerable language accepted by Turing machine. Okay, so that is the thing which is related to the unrestricted grammar. In the case of unrestricted grammar, the production in the form alpha tends to beta, where alpha is not equals to null. And in the case of beta, beta should be proper subset of V union T star. So that is the thing with respect to the unrestricted grammar, and which is also called as a recursively enumerable language accepted by Turing machines. Fine. So that is the one example we have mentioned here. You can go through this example also. Okay. The next one, context sensitive grammar, or it is also called as a type 1. So in the case of context sensitive, you can see here Again, it is in the form alpha tends to beta. Okay. And what they have mentioned, the length of beta should be equals to length of alpha or more than alpha, except for a unit production less tends to A. So length of beta means length of RHS side should be greater than length of LHS, that is alpha. Beta should be greater than alpha, except the production S tends to A. If there is a unit production, then it is an exception. Now see here, S tends to null is allowed for star symbol. These are the some terminologies with respect to the type 1 or context sensitive. Alpha 1 A, alpha 2 tends to alpha 1 B, beta alpha 2, where beta is not equals to null. So A is replaced by beta with alpha 1 precedes A and alpha 2 succeeds A. Alpha 1 and alpha 2 may not be empty. So don't be more confused, all of you. While asking or while writing type 1 or context sensitive, you have to keep in mind it is in the form alpha tends to beta, where size of beta is greater than alpha. Okay. In some exceptional cases, that is, for example, S tends to A, that is a unit production, this is going to hamper. You have to write that much only. I have written here too much, but you have to go through that. Okay. And which is also recognized by Turing machine. Which is nothing but the halting acceptance problem. Okay, so that is nothing but the context sensitive language accepted by Turing machine with the halting acceptance, or it is also called as a type 1. Now, moving towards the next one, context-free grammar, or it is also called as a type 2. Context-free grammar or type 2, every context-free is a context-sensitive. Okay. Reverse of the context-free is again context-free. Yes. It performs union, concatenation and clean operation. Okay. Now see the production. Alpha tends to beta, where alpha is a single non-terminal symbol. Thing is what? Alpha is a single non-terminal symbol. So basically, in the previous two cases, there was no restriction for alpha, but in the case of context-free grammar, there is a restriction for that context-free grammar. Context-free grammar, alpha means LHS should be equals to single non-terminal symbol. It should not contain terminal symbol. That is alpha tends to beta. Fine. So alpha, which belongs to A, B, C and so, means uppercase alphabet should be there, and beta should be a subset of phi comma T star, means beta may be any type of combination, terminal and non-terminal sets combination. NPDA accepts the CFG. Non-deterministic push down automata accept the CFG. Keep in mind this one. So these are the some examples of that type 2. Now moving towards the last one, that is a regular language, or which is also called as a type 3 language, which is accepted by finite state automata. Okay, so you can see here, it contain all the properties of type 0, 1 and 2 language. Okay, production of the form alpha tends to beta. Alpha is only a non-terminal symbol. Alpha is a single non-terminal symbol. Left hand side contain only one non-terminal symbol, means alpha is containing a single non-terminal symbol. RHS contain at most one non-terminal, that is very important. RHS also contain at most one non-terminal symbol. It may be rightmost or it may be leftmost. RHS may be, that production may be like rightmost or leftmost. A regular language is generated by the grammar and recognized by FSA. This is simply denoted by regular expression. Okay, so that is the thing with respect to the type 3. And you can see here, it is classified into two types. First one is the left linear grammar and second one is the right linear grammar. So in the case of left linear grammar, you can see here on the LHS, a single non-terminal symbol tends to BC, A tends to C. That is the example of left linear. And in the right linear, you can see here, S tends to small a, capital P, and A tends to small b. So these are the examples of
Chomsky hierarchy? That is very important question. So whatever the three questions I have discussed earlier, so you have to keep in mind that definitely one question will be there from these three questions. So that's all for that three questions. We will continue in the second video. Thank you so much.